Alright, we're going to talk about operations and their order. I'm just throwing out operations that you've heard of before. I really want to get into the nitty gritty because it's interesting and it's all I can do to not talk about it right now, but I won't. Okay? So, we've got adding, and the inverse of adding is subtracting. Multiplying, which is just fancy adding, which I'm going to get into, and dividing, which is just inverse multiplying. And we have exponents, which is extra fancy multiplying, which was extra fancy addition. And then roots. Roots, poor roots, they don't get talked about till super later. They aren't even mentioned in this thing. So maybe you've heard this before. Pemdas. Let me tell you right now, here and now, this is wrong. It's not that it's wrong, it's that it's incomplete. And by incomplete, then I like to say that that's wrong. It's not, it should be like this. Because division is the same as multiplication and subtraction is the same as addition. So it really should be Pima. Pima. So we're done with that. Pemdas, it's Pima. Okay? Pima. Alright, so why? Why that? Why that order? Why does that matter? Well, it's based on what these things actually are. This is not arbitrary. Nothing that you learn in math or science is arbitrary. If I write a poem, right, and I want to talk about the day, I could say, it's a lovely day. I could say, it's a beautiful day. I could say, it's a quintessentially phenomenal day. Or I could say, the day was dark and brooding. I'm describing the day. I get to choose. It's arbitrary in that regard. This is never arbitrary. We dream things up, but then we take them to their logical conclusion. Okay? So, everything is counting. If you know how to count, you know how to add. If you know how to add, you can find out how to multiply. If you figured out how to multiply, you can easily start to learn exponents. Okay? Here's why. Can you count? I'm going to count 1, 2, 3, 4, 5 dots. I have 1 plus 1 plus 1 plus 1 plus 1, and I say that's 5. Awesome. I'm going to do this again. I'm going to look at this. What about this? What about this? I have 1 plus 1 plus 1, which I say, this is 3 dots. And then I did it again, plus 1 plus 1 plus 1, which is 3 dots. Which is plus 1 plus 1 plus 1, which is 3 dots. I have 3 plus 3 plus 3. I have 3 dots 3 times. What if I just kept batching in 3s? This adds to 1, 2, 3, 4, 5, 6, 7, 8, 9. I count 9 dots. Since these are the same, I just counted them in different order. 3, 3, and 3 also has to be 9. But if I wanted to say, I did 3, 1, 2, 3 times, I need a new symbol. I'm going to use this symbol. That's also 9. That's a perfect square. Multiplication is just advanced addition. So when it comes to our order of operation, it has to be more powerful than straight addition. Because it is more powerful. It's batched addition. Now, what if I said, okay, I want to batch this 3, and I'm going to do this 3 times. So now I'm going to have 3, in which case there were that, plus 3, in which case there was that, plus 3, in which case there was that. And I have this 1, 2, 3 times, I'm going to do it again. 3, 3, 3. That's a lot of dots. That's a lot of dots. And not the good kind, the candy. I love tropical dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and they all sit. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. If I did my 3 times 3 3 times, I got 27. But why would I write this number that way? If I have 3 and I can just write this new symbol, what new symbol can I come up with for this? I know 3 to the 3rd power. I did this operation 1, 2, 3 times, and I got 27. Exponents are batched multiplications. So of course, exponents have to be more powerful than multiplication because exponent is batched multiplication, which has to be more powerful than addition because that's multiplication is batched addition. So we put repeats on adding and we call it multiplication. We put repeats on multiplication and we call it exponents. It's just different symbols for really big additions. We don't have to write. Do you really want to do thousands of dots when the number gets big? No. That's why the order's that way. It's not because it's arbitrary. It's because of the fact that it's what they're defined as. So what's the P? Why does that supersede everything? What is the P? You remember this, don't you? Parentheses. Well, parentheses is the communication between us. I itch my eyes a lot. Parentheses is the communication between me and you and me. Maybe the book and me, the book and you, worksheet and you, worksheet and me, other teachers and us. Parentheses are saying, I want you to do this first. I figured out this really, really cool formula for space-time. It's going to allow you to travel to Mars. This part has to be computed first, and then you can multiply it to that. So parentheses tells you what to do. Let's try an example. Ready for this? Let's just throw out some numbers, yeah? Did I hear it? Oh, I heard a 5. 5 times 3 plus 2 minus 7 squared. Like you do. Okay? So, we'll do this one step at a time. And then I'm going to give you a different one. 5 times 3 plus 2. Yes, you can do more than one at a time as long as you know that you're doing it right. But that comes with practice. Remember? Like a string. Minus 49. How did I know that was 49? Because I memorized it when I was a kid. But really, it's just a big square of 7 boxes. 1, 2, 3, 1, 2, 3. And then if you do all this, you get 49 boxes. I don't feel like counting all those 49. Do you? It's 49. 5 times, now, parentheses. Oh, I should have done parentheses first, shouldn't I have? I did the 49 first. thankfully it didn't hurt us. Why? Because it was separated by the subtraction. 5 times 5 is, survey says? It's a negative number. Da, 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 da. Now, what about this? If you want to look at this more closely, pause the frame now. All right, I'm erasing it. How about this? Now you say, Ms. Thompson, you told us to forget about subtraction. And in Pemdas, where does subtraction go? It goes after addition. And this is what throws people off. This is why I hate this Pemdas thing. Because subtraction is just inverted addition. And when you have two things that are the same, do you know what the rule is? You just go from left to right, like reading, okay? So, actually let's make this, yeah, no, that's right. So, in fact, let's get rid of the 6 for a second. Let's just deal with this. Some of you are going to want to say that this is not correct. This really is 3 minus 4 is negative 1 plus 1, which is 0. That's why I don't like PEMDAS, because there are generations of young people who did the addition first. And based on what their teacher told them, they would be correct, but they're not right. And they get really confused, and justifiably so. They get a little opinionated about PIMA, because it should be PIMA, not PEMDAS, okay? So, why is multiplication more powerful than addition? Because multiplication is a series of additions. Why are exponents more powerful than multiplication? Because they are a series of multiplications. Why is parentheses the big poobah? Because I said so, or you said so. You're communicating to me. Why do we drop the D and the S? Because they're just inverted versions of different operations. And if you come across division or subtraction, they're the same as multiplication or addition, and if it comes down to picking one, you go from left to right. Now I lost the luster because I have to turn it off.